In today's video, we'll be looking at problems from Newton's laws of motion, starting with the first one, which reads, a 45 kg woman stands on a spin scale inside an elevator. The scale reads the force with which it pushes upward on the woman. What does the scale read when the elevator is accelerating? A, upward at 3.65 meter per second squared. B, downward at 3.65 meter per second squared. Well, this is our solution. For part A, they are saying, what does the scale read when the elevator is accelerating upward at 3.65 meter per second squared, right? Okay, so imagine this is an elevator, right? Then inside an elevator there is a woman, right? Okay, inside an elevator there is a woman who is standing on a spin scale. Amazing. So when this elevator is moving upward at a certain acceleration, okay, so when it's moving upward, right, there will be a force which will be acting downward, which will be as a result of the same acceleration which is pulling upward. Okay, so in this case, when this thing is moving upward, right, what will this scale read? This scale will read the weight of the woman. So it will be, so the reading actually will be the weight of the woman plus the force which will be pulling downward due to that acceleration, which will go as the force in this case. That will be our reading. So what is the weight of, how do we find weight? Weight is mg, right? Force is ma, mass times acceleration. What is the mass of the woman? The mass of the woman is 45 kg, gravity 9.81 depending with your school. Mass of the woman is still the same. The acceleration in this case is 3.65. okay, so we'll have 45 multiplied by 9.81 plus 45 multiplied by 3.65. okay, me, I'm getting 605.7 Newton. This is for the first part. Okay, so this is how you find the reading. Okay, so just as you just assume you get. So it's more like you are reading the scenario. You are reading the scenario. Okay, when it is moving upward at a certain acceleration, it means that there is a force which will be acting downward as a result of the same opposite acceleration. Okay, in other words, the force which will be pulling this thing upward is the same force that will be pulling the woman downward. Okay, so there is that force which is pulling the woman downward plus the woman's weight. This will be the reading for the scale. What about for the second part? Well, for the second part, what will be the reading when now this elevator is moving downward, right? So just like we have said, when this thing is moving downward, there is an opposite force, okay, which will be as a result of this acceleration. In other words, the force which will be acting downward on this system, there will be another same force, same magnitude force, which will be acting in the opposite direction. right? So in this case, the woman's weight will be acting in this direction, but this force will be acting upward. As a result, this force is opposite to this one. Because of that, the reading will be the weight of the woman minus that force, because it will be reducing the amount of weight which will be read on the scale. This force is more like it's kind of trying to move the woman from that scale, and it is this force, when it is larger than the weight, that this woman can do what, can kind of fly, so that's the thing. Okay, so our reading will therefore be equal to, what is our weight? Our weight is this, right? So this minus this, so we'll just say 45 by 9.81 minus 45 by 9.81. 45 by 9.81 minus 45 by 3.65, and my answer is 277.2 Newton. So this is how you deal with such a problem. Thank you so much for watching.